Thank you so much. I'm so excited to be speaking here. I love wearing a headset. I feel very good about this headset. Okay. Hello. My name is Moon Dave. I use she, her pronouns, and I'm the processing project lead at the Processing Foundation. Welcome to my presentation. Expanding processing's future with the rendering R&D project. Yeah, that's right. We're researching, we're developing R&D. Okay. What is processing? Oh, yeah. Who here has heard of processing? Show of hands. Okay. Okay, that's cool. Yeah. Wait, are we? Here we go. Yeah, so it's a creative coding framework. You've been seeing like a whole bunch of creative coding tools this weekend if you've been paying attention. I won't say more. But if you want to know more, I recommend Raphael's talk from last year, LGM 2025. It is very polished and it is objectively good. It's called The State of Processing, How We're Bringing a Creative Coding Icon Back to Life. Definitely recommend it if you want to listen to someone really competent speak about processing's history. It's not me. And here's a slide, a frame from that video. So you can just see how cool it looks. And you know, this is just a frame. That might be an animation, that might be animated. Okay. And then here are some like examples. It's another frame from the same talk, but I was being lazy. So here are some examples of things people have done with processing, the Java version of processing. Yeah. Okay. But like, a lot of stuff has changed since 2001. Yes. Like I'm a woman now. Like that's crazy actually when you think about it. But also applets are gone and it like used to run in the web. This is a frame of a frame of a frame showing an applet running voids inside of processing. So you would be able to write this script, this program in Java in processing and then run it in the browser. But you can't do this anymore. It's over. Okay, there's no more web. It's done. Other things that have changed have to do with graphics. The API is different. The hardware is different, and we're growing as people. Okay, no one laughed at that? Okay, I thought it was so funny last night. I was like, okay. Thank you. Okay, here's a slide I stole from Apple. But they were talking about some of the issues with OpenGL, like with like the older version of the API, the immediate mode version of OpenGL. And you know, they make some good points here. Like the pipeline changing, the hardware is totally different. You know, the older APIs don't really support like multi-threaded and like asynchronous operations, which is really important for modern hardware. But more importantly, look at his posture, okay? It's not to make fun of him, but it's to recognize the situation that he's in. He is scared. He is scared because he's about to tell a large audience that they're deprecating support. They're not going to support the old OpenGL APIs anymore, and they're going to make their own proprietary shader language called Metal, and it's only going to work on Apple hardware. So he is kind of stressed. Okay. But let's talk about immediate mode APIs really quick. So this is from, I don't know if people pay attention to graphics engine programmers, but I do. And one of them is Sebastian Altonen. And he's done a lot of really great work along with so many other people who have done great work. But there's this blog that he wrote called No Graphics API, and it had like a good point here I just wanted to share. is, when it comes to like making new like games and stuff like that, it's just the rendering hardware interfaces of existing game engines were designed for fine-grained immediate mode rendering, while the new low-level APIs required bundling data and persistent objects. Very true. This is also true for processing. So we're kind of in the exact same situation where we're built on top of an immediate mode graphics API. And so we're kind of having to figure out how do we exist and like how do we continue to do graphics in the modern world. Okay, what else has changed? I don't know. WebAssembly has become a viable technology. You're seeing it more and more inside of the web browser. I mean, there's so many really cool companies. Also, companies don't matter. I don't care. But like, there's this company, Arcol. They made like CAD software, and it's built on top of Rust, and it's like 3D CAD software, and it runs in the browser using WebAssembly. This is an amazing architecture, and I think I just want to do more of that in my free time. Cross compilation is much easier now, especially with projects like LLVM. So you can compile for any target, any platform. This project is really mature. I'm sure many people in the room have heard of it. Maybe not. Rust is an amazing programming language, and the ecosystem and ecosystem, and it makes low-level systems development much more accessible to anyone, and that's really important to us, especially at Processing Foundation. Also, Rust uses LLVM, and I think I just want to point out that LLVM is not the only thing that's wonderful here. It's like, because I was looking into the Rust compiler internals the other day, and I was just kind of like, oh, it chooses its target. So depending on what you're targeting, it'll use LLVM for the backend, or like there are other compiler projects out there for other targets. And so they've got like 3 tiers. There was a whole list, like 3 tiers of like support for different targets, architectures and stuff. It's really cool. Okay, also WGPU is an amazing library. I will say more about this. So this is a Rust library, and it is something that was meant to like address this new technology called WebGPU, which is going to be the successor of WebGL. I'm sure everybody here knows that. Maybe they don't. I don't know. But let me just talk about this really quick. Don't worry about this giant diagram too much, but the most important thing to keep in mind here is that you can write Rust code that will use WGPU, and then this solves the fragmentation problem that's been created. There's Metal, there's Direct 3D or DirectX, there's Vulkan, there's also WebGPU, there's WebGL. So this is one of the most important projects that's happening out there, in my opinion. Like I think there are other efforts probably that solve this problem, but this is one that's really great, I think, and it enables a lot of possibilities if you're interested. Let's keep moving. Also, Bevy is something that's really cool for us. It's built on top of WGPU, so we don't have to do. They've done all of the low-level graphics programming, and they've created a really modular graphics engine that is. I like to think of it as like building blocks for a graphics engine. So if you want to make a game engine, you can take whatever pieces you want and it can solve your problem the way you want it to. And it also runs in the browser. And if you go to their website, you'll see a lot of really cool stuff. So what are we researching and developing at Processing? So let's finally get to it. Okay. I just made this diagram last night. I'm not very good at it, and everyone's mad at me about my ability to make diagrams or inability. But we've made this processing Rust core, and the idea is that using FFI, it will using FFI, and like in the Java ecosystem, there's a thing called Project Panama. I don't understand that name, but it can call into this Rust core and it can do the rendering. And we've already proven that. It's in a long-lived branch, and I'm embarrassed about the long-lived branch, but at the end of this month, we're going to have it merged into main so you can try some of the experimental work. Also, this is not happening. The color green is wrong for P5.js because it's not actually happening just yet, but we are in discussions for compiling this processing Rust core into WebAssembly, and then using WebAssembly to see if P5.js will benefit from it. And this will be really huge if it works out and if it's actually something that the project will benefit from. If it's not, then that's kind of a big loss. Oh, and then yeah, that's Bevy at the underneath. So let me know if it's too small. I'll make it bigger somehow. But let's talk about the vision, right? So like this also expands things for us too. So beyond just like our Java and like it's possibly P5.js, but there's also like Python. There's a library in Rust called PyOxide, PyO3. And you can use that to like create like a Python library. And that's a really cool possibility. What if you could use FFI and make like a scheme library to do creative coding, and you can use this Rust core underneath it, right? So there are many possibilities. You can also make anything. That's what this yellow box is. This yellow box is anything you can dream of, like a drawing app or anything. It doesn't need to be like locked into any kind of ecosystem. Like you don't have to run it inside of the PDE, for example, when you make something. So that's just something really exciting. The other thing I'm really excited about, this is it. I promise. I'm not excited about anything else. But like Rust embedded has like the ecosystem for embedded programming is really wonderful there, and it's like made it super easy to like go and do physical computing and do hardware projects. And I've met some people, millennials, they're doing like incredible projects using Rust and the embedded ecosystem. I'm like, okay, I wish I was smart. But this is really cool. So I'm just kind of imagining, what if we were able to offer this kind of physical computing, like facilities within like the really easy kind of like, not easy, but like beginner friendly, but also beneficial to experts kind of like processing like experience. And if there's a way for us to like really bridge that gap and like make that happen, that would be super cool. IMHO, in my humble opinion. Challenges. Rust is not beginner friendly. No, it's not. It's kind of hard to learn. I'm a C programmer and I was like, this is hard for me, but I've gotten the hang of it and I love it. Also, we're working with educators in some institutions in New York at the moment, and we'll probably want to do this with more educators all around. But we're going to have students learn Rust and then try and create some tutorial material for getting into it. And so that way we can kind of help the whole Rust ecosystem with the beginner's problem. We need to explore, I already talked about this, but we need to actually explore the feasibility of using WebAssembly instead of P5.js. There are conversations that are coming in the next 2 weeks, maybe, but I have to send out a scheduling link to a couple of the contributors. Also, the PDE, so processing Java, has some documented challenges around floating point textures. We currently use integer-based textures, and so it's an interesting historical artifact. But like we do bit packing for all of the RGBA channels for our textures, and it's tightly coupled. So it would be like a breaking change if we were to truly address this. But I think that's like a good idea. I think it's good if we address this, because no matter how great like the Rust rendering core is, this will be a limiting factor for like what's possible. Because a lot of modern rendering techniques require floating point textures, HDR, all of that. Also, the processing experience, what we know processing to be is a result of immediate mode rendering. Like you type in light inside of your draw function and now you have a light. That's not how modern rendering works at a low level. So we've actually solved this challenge. We pay a performance price, take a performance hit, but every time we call draw, we just flush all the commands. And so we're kind of like simulating immediate mode so that people are kind of getting the same experience. Demo, there's 5 minutes. Yeah, I think, okay. Okay, wait. And then, is this where my mouse is? Okay, this is going to be hard for me, but not that hard. because I live for this. Okay, so you know how I mentioned that we were envisioning a Python thing? We kind of decided to try it out at least, and so we tried it out. And so let's look at the examples, and I'll try to choose one that works. Like UV run. Has everyone heard of UV? Anyways, it's like the new Python shapes. Cool. Okay. What else do we got? UV run. Oh my God. Lights. Okay. Yeah, let's do lights.py. Wow. Okay. I made this one. It's really trash. I'm sorry. There's probably more beautiful things to be done with lights, and I didn't do that. Let me choose something that someone else did that's more beautiful. UV run animated mesh. Wow, it's so beautiful. Okay. What else can we do? Also, we do stuff like GLTF loading, but it's broken right now, so I can't demonstrate it. But that's kind of part of the instability and excitement of this project is we're running on like the dev branch of Bevy. And so like it's all coming in hot all the time. Is that what we say in Europe? It's coming in hot? Okay. Also, I have like some MIDI stuff working. I cannot demo that camera controls. And we have user input. Let's try it. Where's my mouse? Okay. Okay, that worked. Okay, there's like another's keyboards. Yes, that's right. Yes. Yes. What does this one do? Okay, that's okay. There's my mouse. Okay. Thank you for tolerating me. I'm having so much fun up here. Oh, I have to show you this one. Okay, one more. Custom. We have 3 minutes. We got this. Okay. Okay. Is it? Okay, this isn't animated. I can't see it very well. That's animated. We're using a shader to use for the material here. And this is using the Legia library. I can send links to that later. But okay, wait. So what I want to say is HX assets, shaders. We're using Weasel. So you can use Weasel as your shading language. And I think that's really cool. But no one here seems to think that's cool, and that's okay. You'll one day see how great this is. But yeah, we were able to just kind of include Legia, and so there are like these third-party like shader libraries and stuff that people have like come together to put to create like these are like high-quality shaders that do a lot of the things that we need to do as artists, and you can just fold that into your project now. And the reason why Weasel WESL is so important is that it's a much better shading language for WebGPU. And again, using the WGPU, we can use that to cross compile into like every shading language, and that's really cool thing to lean on. What else? Okay, let me try one more thing, which is this is my most elaborate goal. Okay, so we're gonna do this, and then I'll do that. So we'll go like this, and then we'll say UV run lights. Okay, and then that's there. Oopsie daisy. Okay, wait, where am I? Okay, wait. Oh wait, I think it's changed screen. Okay, wait, let me go like this. Okay, let me go like this. Okay, and then I think live coding works as of the other night, like yesterday. So we'll try and figure out like let's change this box to like 120, and then see what happens. Oh, that didn't look cool. Okay, let's see. What happens if we go like this? Something dramatic. Oh, we changed something. Okay. Okay, but see, it's not totally working because like we have like this problem where like these old processes, they're not destroying the window. So we just have like this like freeze frame. But anyways, live coding is kind of on its way or whatever. So, we have 18 seconds left. Okay. What else can we talk about? I think it's over. Thank you.
Thank you very much. That was for very low level talk, very entertaining. I love it. Okay, great. Do we have questions? There's a question, right?
Oh no.
Where can people find out more about this work and potentially get to contribute?
That is a really great question. Let's try Firefox. Okay, so if you go to github.com and you go to processing/lib processing, this is the core library that we are working on. And this is the name of the Python library. I invented this name because none of these names are official yet. We're still figuring out the name. And this is a Pokemon I made up. And I'm sorry, but it's really easy to set it up and get started. Moreover, we have some links to, we're porting the processing examples to this Python stuff as a way to kind of iterate and like improve everything as quickly as we can. And so that's another place where you can do it. Please come to us afterwards and we will show you the link because I cannot handle that right now. The other thing I want to say is there's this thing called Sovereign Tech Fund, and these folks, agency, they have the fund. These folks are amazing because we actually got all this work done as a result of their funding us, and so this is also that we can improve processing and kind of keep working and moving forward and growing and expanding. And this has been a really wonderful bit of support that we've gotten. But I'm going to close this and I'm going to shut down my computer. Any other questions?
Thank you very much for your presentation. I have a question. What does this mean for the IDE and the language?
Yes. Great question, and I'm so glad you asked it. It doesn't mean anything. Because of the architecture, you just write Java. So I showed you a lot of Python stuff because I can't show you the IDE stuff right now. But that's again at the end of this month. Around then, we're planning to pull that into the main branch of processing. You just write processing the way it's done. The idea is when you put a triangle on the screen, the only thing we're changing is how that triangle gets onto the screen. So you don't have to think about it.
With one more question right there.
Is the P5.js stuff more that P5.js is already cool, or is it more like that it's a problem to call into Rust?
Wait, help me understand your question.
Like you said, you're still discussing P5.js calling into the Rust core. Is that just because P5.js is already cool and you don't want to make it worse, or is it like some problem into calling?
P5.js is amazing and it has its own incredible ecosystem and like they're doing all these things and it's like, I don't know, it's kind of just because like I come around with this new library or something like that, if it's not going to help out and like make their lives easier, then why would I force anyone to like, you know what I mean? Did I answer your question?
Yes.
I'm sorry. Okay. I'm not sorry.
Okay. Thank you very much. We're going to have Mark Alexander switch over quickly because just 1 minute left. But give it up for Moon.